Section part of the lodge. So part one of the lab was finding the unknown mass of a black hole and by analyzing the motion of an orbiting star in a computer model, and the star mass was 2 times 10 to the 30th kilograms. Part two of the lab was making a model in which you could escape the black hole if you were on a spaceship launched from a planet orbiting the same black hole, and your velocity was in the same direction as the planet's initial velocity. However, your engines failed to launch at the same time as soon as you launch, so there's no force due to the engines. So here's diagram one. It's just the star opening a black hole. Part two is the spaceship represented by the cyan line, and the magenta line representing the planet, their orbits, compared to the black hole, which is the black dot. Here's some key formulas. Fnet parallel, Fnet perpendicular, and the key thing to know here is that the total force is Fnet perpendicular plus the Fnet parallel, and then and it's also equal to the change in momentum over change in time, which is the same thing as dp/dt. Since everything's in space, the only force acting on these objects are gravity, so that's why it is a net force. So we P, V init, and V final are already initialized for us in the program. The momentum of initial and final is obviously just the initial velocity, finals times mass, respectively. The delta V is just the change in the final minus initial, both for velocity and for momentum. dp/d is the rate of change of momentum with respect to time. That's just going to be change in momentum divided by change in time, delta p over delta t. Fnet is the same thing as dp/dt. It's because Fnet is equal to the derivative of momentum with respect to time as per the momentum principle. Parallel change in momentum, aka the parallel force of the net force. So this is pretty easy because the parallel force is in the same direction as motion, as defined previously in the slideshow. So we simply take the unit vector or the direction vector of momentum, and we just multiply that by the change in momentum to get the parallel force. Now for Fnet parallel, like I said, change in momentum parallel is the same thing as Fnet parallel. Perpendicular, since we know that Fnet equals Fnet parallel plus Fnet perpendicular, you can just literally just do F perpendicular is equal to the perpendicular force, the total force minus the parallel force to get the perpendicular force. Wow, that's a mouthful. And here is the mass of the black hole. That is done using universal gravitation law and manipulator. And so we solve for just the mass of the black hole. The star completes a full orbit around the black hole, and for every instance of time, it spits out a different value for the mass. So the way I got the mass of the black hole is I just average all those, and that's about 7.32 E33. All the physics properties apply and the equations apply, except we're worried now about three different bodies: the spaceship, the planet, and the black hole. And so as you can see, the mass of the black hole from the previous part was plugged in right here, BEH.m. And I really just kind of messed around with the velocity until I found values in which the spaceship could escape the influence of the black hole safely. So here's the loop of the calculations, and then if you look over here, if you run this program, the cyan being the spaceship and the purple line being the planet, as you can see, the spaceship successfully escapes the black hole's influence, and everybody survives, and we all have a great day. I'm just gonna wait for this to finish. There we go, we're done. We're saved. Change of momentum versus net force. Well, these two quantities mean the same exact thing. Same with their parallel and perpendicular components. It's just easier to measure the rate of change in momentum versus net force because the rate of change in momentum is related to velocity, whereas force is related more to acceleration. So it's just easier to observe. So here's the what if. And I think I'm not really sure how you would go about this because I'm not really sure how to deal with gravitation with three objects, but the idea of it is to set the centripetal force equal to universal gravitation of a planet and black hole, so that the planet maintains constant velocity around a black hole, which gives you off a force of universal gravitation. And this is really hard for me to calculate because I don't really know how to deal with the gravity of two bodies on one object. It seems that there's just a lot of moving parts because the distance between the force is constantly changing. So it'd be a lot of update, and I wouldn't know how to do it with three bodies, but this is the general idea of how I think you can get a spaceship in constant velocity of orbit around a black hole.